This problem asks for us to return whether an integer is the same forwards as backwards. We'll explore a few solutions, starting with the string one. So string num is equal to toString of x. This is how you turn just about any number data type into a string. Now we'll create a copy of num, call it rev for reverse, and set it equal to num. Now we can reverse it using the reverse method, which takes in an iterator to the beginning. We can find that using rev.begin and an iterator to the end with rev.end. Now this will reverse the section from begin to end, and this reverse method works with just about any vector, and it turns out a string is just a vector of characters. So now all there is to do is return whether or not num is equal to the reversed version. Now we can run this to check for typos. And after we see that everything passes, let's try a more numerical approach. The first thing to notice is that any negative number should return false because there will never be a negative sign at the end of the number as well as the beginning. So if x is less than 0, return false. Otherwise, another thing we have to notice is that the reversed version of x may be greater than x itself. And this could cause integer overflow, which will be a problem for us. To make sure that doesn't happen, we'll simply type uint64_t, which is a 64-bit integer, and it's unsigned, which is fine because we just verified that x is not negative. Now, just to be clear, an integer on a 64-bit system might be 64 bits, but LeetCode only uses 32-bit integers, and that is defined down here where you can see that x is between these two values. So we know we're safe with an uint64t. We'll call this copy and set it equal to x. So we're just going to store a copy of x. Now let's build up a reversed version of x. So I'm going to say uint64t rev for reverse, and we'll initialize it with 0. Now while x, which is synonymous with while x is not 0, we're going to say rev times equals 10 to shift it left so we can add a number to the end. And we'll say rev plus equals x mod 10, which is adding the last digit of x to the last digit of the reversed version. Now we can take that last digit off the end of x by saying x divided by equals 10. Now, all that we have to do is return whether or not the copy of x is equal to the reversed version of x. Now, if I run this program, you can see that everything passes, and let's submit it to see how it compares with the other solutions. As you can see, it does all right, though with C++, on some of these problems, you can't really trust the solution's distribution here. All you can trust is that if you're within this first hump, then your program has the same runtime as the best set of solutions. Because as you can see, if I submit this multiple times, my answer will vary in results. Now it's much slower. Thank you for watching. Please subscribe for more educational content. Have a nice day.